question is from AIPMT 1992 question paper, in which two spherical conductors A and B of radii 1 mm and 2 mm are separated by a distance of 5 centimeter and are uniformly charged. If the spheres are connected by a conducting wire, then in equilibrium condition, asked to find ratio of the magnitude of electric fields at the surface of sphere A and B. Here, both the spheres have different radius, thus will have different charge and different potential. When such two spheres are connected by a conducting wire, charge will flow from higher potential sphere to lower potential sphere till potential of both the sphere becomes same. Here, we will not consider the effect of induction of B on A or A on B, because radius of a sphere is very less compared to the distance between the two spheres. Let V be the common potential of sphere A and sphere B. Let radius of sphere A be R1 and radius of sphere B be R2. Let Q1 be the charge on the sphere A and Q2 be the charge on sphere B. From the formula for the potential at the surface of sphere A and sphere B is V is equal to 1 upon 4 pi epsilon 0 into Q1 upon R1 equal to 1 upon 4 pi epsilon 0 into Q2 upon R2, implies that Q1 upon R1 is equal to Q2 upon R2. Let E1 be the electric field at the surface of sphere A and E2 be the electric field at the surface B. We know that electric field is directly proportional to Q upon R square. Therefore, E1 upon E2 equal to Q1 upon R1 square divided by Q2 upon R2 square, which can be written as Q1 upon R1 into R1 divided by Q2 upon R2 into R2. We have already proved that Q1 upon R1 is equal to Q2 upon R2. Therefore, E1 upon E2 equals to R2 upon R1. On substituting the values of R2 and R1, we get the ratio of E1 upon E2 as 2:1. Therefore, option C is correct.